Hey Advanced Algebra 2B. So your notes tonight are going to help you in class tomorrow. These are actually going to be preview notes. We haven't talked about this in class very much yet. So we're going to talk about geometric sequences today. And a geometric sequence is a pattern where you multiply or divide by the same number each time. So before we were looking at patterns where you were adding or subtracting each time, and now we're looking at patterns where you multiply or divide by the same number each time. So for instance, here, if I have the pattern 4, 20, 100, 500, then notice that 4 times 5 equals 20, and 20 times 5 equals 100, and 100 times 5 equals 500. So what we're doing every single time from one number to get to the next is we're multiplying by 5. So if I wanted to get my next pattern, I would take 500, I would multiply it by 5, and I would get, let's see, 25 with 2 zeros on the end, because 5 times 5 is 25 with those 2 zeros. Okay. So this multiplying by 5 each time, when you have repeated multiplication, like 5 times 5 is 5 squared, and 5 times 5 times 5 is 5 cubed. And whenever you have this like act of repeatedly multiplying by the same number, we're going to use a power. Now we did sort of play around with this a little bit informally last week and the week before that, but we haven't really formalized or looked at a formula or anything like that for repeated powers. So here, if I notice this like 4 times 5, this is really like, this 20 is really 4 times 5 to the first. And then here, I could think of it as 20 times 5, but I could also think of it as 4 times 25, right? Because 4 times 25 is 100. So 100 is equal to 4 times 5 squared, because 5 squared is 25. And I could think of 500 really as 4 times 5 cubed. Now this one might wig you out a little bit, but let's look at it. 5 cubed, 5 times 5 times 5 is 125, right? And if I do 125 times 4, 5 times 4 is 20, bring up the 2, 2 times 4 is 8, plus 2 is 10, bring up the 1, 1 times 4 is 4, plus 1 is 5. So 5 cubed is 125 times 4 really does equal 500. Okay. So then 2500, if we were following this same pattern, what would you expect to go right here? Well, I'm noticing that every single time there's a 4, and there's always a 5, right? And I would expect the power to be to the 4th. And you could check that on your calculator, and sure enough, if you multiplied this out, you would get 2500. So now each one of these, the 20, the 100, the 500, the 2500, these are all a subs, right? This is my a sub 2, this is my a sub 3, my a sub 4, and my a sub 5. And notice each time the 2 and the 1, 3 and 2, 4 and 3, 5 and 4, notice each time these powers are all 1 less than the subunit that you're talking about. So if I wanted to write a formula a sub n, I would say a sub n is equal to, well, it's a 4 every time, right, times 5. And then the power is always 1 less than the term, and so I would say n minus 1. Okay. Now, this is going to be the formula for my geometric series or sequence, okay, for this problem. So if I were to write a formula, this would be the formula. Now, it's actually going to always work like these for things that are geometric. So if they have a starting number and then they multiply by the same number each time, this is always going to be your starting number, or it's also what we've been calling our a sub 1. And this is always going to be the number you multiply, so it's going to be the repeated multiplication number. And this guy is always going to be n minus 1. It's not going to change. So if I gave you guys an example, like example number 2, And I gave you the pattern 3, and then let's see, 6, 12, 24, 48, and so on. And I asked you to find the nth term, which is really just asking for your a sub n formula, right? Okay. Would you guys take a second and look at this and see if you can identify the pattern? What you should notice is that each time I am multiplying by 2, because 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, and so on. And so if I were to write this out in the a sub n, I would write a sub n equals my first term, so 3, times 2 to the n minus 1. It's a 3 because it's the first term, times 2 because that's what I'm multiplying each time, and then it's always n minus 1 up here. Now I could check and see if it worked. So like, for instance, if I wanted to do a sub 3 to see if I really get 12. That's my goal, right? I plug in 3 times 2, and now 3 is going in for the n, so 3 minus 1. I have to do the exponent first, so 3 times 2, let's see, 3 minus 2 is 2, right? And now I do my exponent again, so 2 squared is 4, and sure enough, 3 times 4 is 12. So it really did give me my a sub 3, it really did work. Alright, that's it for notes for tonight, guys. Go and get these copied down in your notebook, and I will see you in class tomorrow. Thanks!